Hello, this is Paul from Foresight Tech. In this lecture, we are going to go over conics in Cartesian system or rectangular coordinate system, which we learned from trigonometry before. And the first, let's look at the parabola. We have three types we're going to see. The first is parabola, and I summarize the four cases here. And for the detail, for some detail, I will just skip, okay, because we already learned before. Under the first case, so it's open up. You see this parabola open up, okay, and in how to define? So first we need to put directrix. Okay, if we put the directrix is at here, y equals negative p, and we put the focus there, and the position is O0p, and the p is a positive number. Okay, this we define a positive number, and then we use this definition to define all the points on the curve of a parabola. If the point P on the graph and the distance P to the focus PF equals the distance of the the point to the directrix PL, if I say the directrix is L. Okay, and then if you follow this definition, do some calculation, we will definitely get this standard equation, right? X squared equals 4p1. And then so we look at it. So this vertex, the special case vertex is at the origin, right? So if we shift, okay, if we shift the origin, the vertex to some other point, which is the vertex we shift to h and the k. How about the new standard equation? We just replace x by x minus h and replace y by y minus k. Okay, h is for x, k is for y. So this is the general standard equation. Okay, so this is the first case. And let's go a little. So here is this point we call the vertex, and we have a focus, then we have directrix, and if we fix the focus and directrix, we can see the graph. Okay, it's just toward the focus and against the directrix. Okay, so we have the basic idea. Let's go over another three case. If we put the focus here, if we put the directrix there, okay, and then how to draw, use the same definition, how to get the graph. Okay, of course it's open down in this case, right? Okay, and the open down, we definitely have p is less than 0, our definition. Can we see the focus, this point there, we always say the this is p, not a negative p. Okay, it's go to, but not the x-axis, this p should be negative. Okay, again, if we look at the directrix, y always equals negative p. So in this case, p should be negative. Negative goes to positive, right? Okay. And the standard equation look is exactly the same as the first type. Okay. And the open down, open up has the same type of standard equation. And another, if we shift the vertex to hk, and of course replace x by x minus h, replace y by y minus k. Therefore, we definitely have the same equation. Now we see the first two types, okay, all the same, but one is very important. P, the parameter p, okay, and open up, the parameter p greater than 0. Open down, the parameter less than 0. That's the difference. Therefore, we have a different graph, right? Okay, and another two type is open right and open left. Okay, so you know, so this is the same. So you look at the standard equation, and if the vertex in the origin, they have exactly the same. And if we shift the center to hk, they also have exactly the same. And these two types are the same. Let me mention one. Okay, and the focus, of course, is on x-axis. Can you see? So this time is p is for x coordinate, y is 0. Okay, of course it's different from the first two type. And then if we look at the directrix, is a vertical line. which is x equals negative p, right? Always negative p, negative p, negative p. But this time is x equals another. Can we see? If we put the directrix there, okay, x equals negative p on the right side of y-axis. What do we have? And we have x equals negative p, which means p is a negative number. Negative, negative makes positive, right? Okay. So the first p is positive. Okay. So the second, or you can look at the focus. P0, p should be negative because the focus is on is to the left side of y-axis. Okay. So this is the summary. So I hope you get this. And then I will give you one example. So we only have 1, 2, 3, 4 cases. The open direction tells you what the standard equation. Okay. Standard equation, even these two types are the same, but the sign are different. So make sure. Can we look at one example? Here, at the first example, can you see? We're going to find the equation for the parabola with the focus. So we know the focus, and then we know the directrix. So how to find the standard equation? Let me see standard equation, what to do. And usually this is kind of geometrical questions, draw a graph, which will help us to get the solution. I will draw Cartesian system. Okay. I will draw x-axis, whatever. If I say this x, if I draw a y-axis, and so the focus this time goes to the origin. So can I see? I'll put the focus here. This should be the focus, right? This origin, however, is also the focus. And then the directrix is y equals 6. Y equals 6 is a horizontal line. Okay, so if I suppose y equals 6 is at here, this is y equals 6. The directrix, and then now do you remember? Okay, so our parabola cannot open left, cannot open right, cannot open up, only can open down. Why? Because we need to open toward the focus against the directrix. So what do you do? We just do like this. Okay. Open down. You can just roughly get your curve. Okay, you just roughly get your curve. Okay, so look like this, right? So what does it mean? We already determined the type. So the type now is open down, right? Okay. So belongs to the second type, we just see. If it's open down, remember what the parameter p, positive or negative, is negative. Okay. And this is the one we need. Now we can just write the formula. What's our formula? Okay, our formula is this. Should be x, right? This is y. X minus. Okay, I use the general. Okay, the last one. Why? Because the vertex is not in the origin. Can we see? So I have a look. So is this type the second type? And there is not this standard formula, standard equation. Should be this one. Is h and the k. Okay. So we're going to see is x minus h square, right? And then equals 4p, always 4p. Okay. Here's y minus k. Okay, can we see? This is the standard equation for the second type, open down. If it's open down, y is negative. Okay, so like the y minus k is negative. We see this standard equation. That's the formula. Okay, so now what do we need to do? We find the p, find the h, and find the k, right? Log in. What the vertex? So let me first find the vertex, hk. The vertex. So h and the k equals how many? Okay, this is not difficult. We have the vertex here. Do you remember the definition? Okay, the definition, so these two there, okay, the distance are the same. This distance is equal to this distance, okay. Because this 0, that's 6, so this should be 3, right? Okay, so we find this the center. If I say this is the center, up here, the center is h and the k. That means, okay, what is h, k? H should be 0, k should be 3, 0 to 6. The middle is 3. Okay, and the hk we determine. So how about the p? Remember, where is p? P is the directed the distance, or simply say the distance from the vertex to the focus. Okay, so that's p. Of course, in this case, is p is less than 0. Okay, so how many? This distance is 3, but the p is less than 0. So the directed the distance is negative 3. Therefore, we find that p equals negative 3. Okay, and then we have everything. We plug into the formula, see what I get. We will get the standard equation, right? Is x minus 0, which is x squared. 4 times negative 3, which is negative 12. And the y minus 3, which is y minus 3. Can you see? And this is the final standard equation, okay, for the parabola. That's all. Thank you.